Okay, here's a problem of a half-life exponential decay type function. And what we're looking at is starting with some amount and given a certain decay rate, how long will it take to get to half its life or half its amount that it started with? So let's do a real simple problem here. So if we have 50 equals 100 times 0.8 to the power of x. So what we're saying is our starting point, or our y-intercept, if we graph this, starts at 100. And we are multiplying it by 0.8, which also means that we're decreasing by 20% each time. And then going from 100 to 50, that is going to be half as much as we started. And so we're looking at what power do we have to raise this to get to 50. So we're just going to estimate this out to see approximately where it should be. So if we started with 100 and multiplied it by 0.8, it will be, yes, 80. Well, that's not close, but we should continue on. And let's just mark this as our first one, or when x is 1, we get 80. So since that's what we have left, we start with 80, multiply it by 0.8, and we end up with 64. Again, bigger than 50, so we have to continue on, and let's just mark this off as 2. And then we take 64, multiply it by 0.8, and we get 51.2. And that would be our third term. Well, a little bit more than 50, but we're getting close. So we know that x is going to be around 3 and a little bit bigger than 3. So if we do it one more time, our fourth stage, we go 51.2 times 0.8. We will get 40.96. Much too small, so we know we can probably stop right there and give an estimate that it's between 3 and 4 and definitely closer to 3. Well, at this point, if I take our equation, we can estimate it a little bit further. Again, let's start 100 times 0.8 to the power of x. If we divide this side by 100 to simplify things, we would get 0.5 equals 0.8 to the power of x. So we're asking ourselves, how can we estimate by evaluating x in this expression to see how close we can get? So we know from over here that it is close to 3. So let's try 3.2. So 0.8 to the power of 3.2 on the calculator would give us approximately, let's see, 0.489. Not quite half, or 0.5. So let's go a little bit smaller. So let's go 0.8 to the power of 3.1, and that gives us 0.5007. A much better estimate, so we can probably go with this right here. That it takes about 3.1 stages or units of measure to get the half-life. If we start with 100, we're decreasing by 20%, or our decay rate is 0.8, to get to 50.